What this will be is a review for the final exam in Math 1103, but also a general preparation for a challenge exam for students who want to move directly into Math 1108. So what sort of skills should you possess to be competent in an exam or a review such as this? Well, this is what we've put together here. So the strategy for this will be to write the question down. Now it's in the form of multiple choice, but you want a strategy to be able to get to the answer. So for number 1, you've written this down, and I'll write it again here. V equals 1/3 BH. And you want to solve for the letter H. Well, this is one term, this is one term. The first thing we'd want to do is get rid of the fraction by multiplying both sides by 3. This side and this side. Now here, the 3's will cancel out. So you're now left with this, and I'll clean that up. And to solve for H now, we have B times H. So B is a factor, H is a factor. We can divide factors out. Here now the B's will cancel out, and we get H. I can clean that up a little bit. No, I lost the H. H equals 3V over B. And here we have the answer. Again, you want to write down this next example. F equals 9/5 C plus 32. And we want to solve for the letter C. So the first thing I would do is try to isolate the C term by bringing this term over to the other side, which I'll show up here, F. Now, when I transpose a term from one side of an equation to the other, we just change its sign. Here it's positive, so on the other side it will be negative. And we have the 9/5 C isolated. Now, we want to get C all by itself. So the strategy for that is to get rid of the 9/5. We want to make this a 1. Now we do so, and I'll change colors, by multiplying something by its reciprocal. That is, just flip it over. So this will be 5/9. So if we do this side by 5/9, and we have to put this now in a parenthesis, we have to do that side by 5/9. And there we have isolated the C. So let's see if I can just do all that. Perfect. Just have to add a sign here. So matching this up, it matches up with letter C. So once again, you're going to write the example, and you're going to try to solve it for the letter W. Well, again, we want to isolate the term with the W in it. So we're going to transpose the 2L to the other side and get P minus 2L equals 2W. That would be your next line. And now just divide that part of the term, because 2 is a factor, W is a factor. Divide by common factors, that is the numerical coefficient of the variable, both sides. So here the 2's cancel out, and you get this. And I can erase that, just so you see where it came from. And which is this? Well, that is A. Now, as we go to number 4, we're getting into equations. And notice what I did when I wrote it. I looked at this and realized I had like terms here, and I combined them and ended up with a 3x. So you're allowed to simplify that. You don't have to show every single step. Now, what I want to do is get all my x's on one side, all my numbers on the other side. And I like to keep my x's positive. So to get rid of a negative 4x, I use its additive inverse, which is a positive 4x. And to keep it an equation, I have to add that 4x to the other side. Now when I do that, this will cancel out and give me a 0. And I get 4 equals 7x minus 52. And to eliminate the negative 52 on this side, I'm going to add 52 to this side, add 52 to this side, so I get 56 now equals 7x, because these will cancel out. And the general rule is whatever is with the x, you can divide both sides by that. And here the 7's cancel out and you get x. And 56 divided by 7 is 8. Okay, that would be letter D. So as you go for number 5, I see we have a parentheses that we need to clear. So I'm going to write the 6, but I'm now going to multiply negative 6 times y and get negative 6y. Negative 6 times 1 gives me a negative 6. So now I have like terms here, a 6 and a negative 6 on this side that I can just eliminate. And again, I want to try to keep my variables positive. So here I'm going to add 8y, its additive inverse, and to this side. This gives me a 2y equals 3, because these will cancel out. Now, to solve for y, I'm going to divide whatever term or ever coefficient is with the y, which is 2. And these cancel out. And I end up with y equals 3/2, which is letter C. Again, you want to know the strategy. A number of things are incorporated to solve equations. So in number 6, I've used a technique of just copying the answer down so you don't destroy your original, and be sure you've copied it correctly. Now, this has fractions. So one of the rules is get rid of fractions by multiplying each term, this is one term, one term, one term, by the least common denominator. So what is the least common denominator between a 6 and a 3? And the answer is a 6. I'm going to multiply each term by 6. Now doing so will result in an equation that is not the same, but equivalent. And all of the denominators will be a 1. So 6 goes into 6 once, so this is a 1. 3 will go into 3 once, but 3 will go into 6 twice. 3 goes into 3 once, 3 goes into 6 twice. So now we have to clear this up. So this will become 5x plus 2 equals 2 times 2x is 4x. Now again, we want to get all the x's on one side. Now another technique is when you take a term from one side to the other, it just changes its sign. So this 4x on this side will be a negative 4x, and a positive 5x just leaves you with an x. Or you can subtract 4x, subtract 4x. This is a shortcut. And we're going to take this positive 2 over to the other side as a negative 2. And then that is your answer. Now for number 7, we have fractions and a parenthesis. So this is all one term, this is one term, and this is one term. So our least common denominator here would be a 5. So we multiply each term by 5. So here the 5's cancel out, and we're just left with y minus 4. Here the 5's cancel out, and we're just left with a 4 and a minus 5y. Now we want our y's to be positive, so I'm going to transpose this negative 5y to this side, where it becomes a positive 5, or add 5, we get 6y. And then I'm going to transpose this negative 4 over, or add 4 to both sides. This gives me 8. I'm now going to divide both sides by 6. And this gives me y equals, simplifying that to 4/3, which is A. All right. Now, in this next example, we're asked to translate the sentence from English into an equation of algebra. M, remember you can try this first, decreased, negative sign, by 9 is equal to 12. So that part is this, and now we're just going to transpose or add 9 to both sides, and that equals 21. So they're starting us rather easy into converting English to algebra. Now for this next one, here's the algebraic expression. You'll have to read these over and pick out the best answer. So pause and see what you can come up with. And this one is B. All right, let's go on. In example 10, what we're asked to do is to solve this inequality now, and then graph it and write the answer in interval notation. So one of the key things about inequality is try to keep your variable positive. So here, if I transpose this negative 4a to this side, it's going to become positive. And then I can add it to the negative 3a, and it just becomes an a. Or you can add 4a and add 4a. This will just become a positive a. Now I'm going to transpose the negative 6 to this side, where it becomes a positive 6, and a negative 3 gives me a 3. Or you can add 6, add 6. So this is the algebraic solution. A is greater than 3. Now, how do you put that on your graph? Well, we said you indicate what number you want, and then it's greater than only, so you're going to use a parenthesis, and then you thicken this line. Now, in your software, when you do this, what you have to do is pick out from a series of parentheses and brackets here. But to put this in interval notation now, we're going to use a parenthesis because the 3 is not included, starting at 3 or just beyond 3. And this is going to positive infinity, which is indicated by the ellipsis. And we show it this way in interval notation. And infinity always has a parenthesis. Remember over here, this would be negative infinity. And again, you can look at some of these other answers that are not the solutions for this, but they are showing the proper interval notation for the graphs that are illustrated there. All right, let's go on. Now, this is 1/4 of our review. If you want to pause now, take a little break, refresh, and then come back, that would be fine, but we'll be going on. And as you look at number 11, this is a word problem, very typical of the kinds we get. So pause and see what kind of equation you can come up with. So something like this. We know that Sheila, S, is 3 times as old as her sister Terry. So S equals 3T, 3 times as old as Terry. Now in 4 years, Stella, so S plus 4, will be twice as old as Terry, and then Terry in 4 years, of course, will have gained 4 years as well. So we can substitute the 3T for the S here, and this becomes 3T plus 4 equals 2T plus 8, multiplying through. And now we have a variable with only one kind of letter. We're going to subtract 2T from both sides, and that will give us just a t. Transposing this, and then transposing this, or subtracting 4, we get 4. So Terry is 4 years old. So 3 times 4 is 12. So Stella is 12 years old. And that's the work, and hopefully some background on doing this type of problem. All right, let's go on. Now, we ought to be able to use two variables for this, the adult tickets and the child's tickets. So A for the adults, C for the child's, and let's see what equations you can come up with. So something like this. A, the number of adult tickets sold, plus C, children's tickets sold. Total tickets, 114. Now, the price of an adult ticket was $7. The price of each child's ticket was $3, bringing in the total revenue of $626. Now, I've lined them up. These are in standard form. I want to modify this top equation so that one of the letters in this bottom equation will cancel out. So what would I multiply this top by? I want to do the easiest thing. And I would say a -3. So the strategy, and again, I don't have a lot of room here, multiply each term in this equation by a -3. This gives me a -3a, a -3c, and this gives me a -342. Now, this equation we don't change at all, but now we write it underneath. So this will be 7a plus 3c equals 626. Now we put our line underneath, and then these cancel out. And now I get 4a equals 284. We're going to divide both sides by 4. And we get a now equals 71. Now, what does this stand for? Well, this is the number of adult tickets. And that's what they ask us here. How many adult tickets were sold? And if you can see right over here for C, it is 71. All right. Clear that up a little bit. All right, for number 13, again, this could be done with one variable, and we're going to use the formula rate times time equals distance. So you have a portion of the plane going this way, one, and another going this way, and the time will be the same. So see what you can come up with. Well, you could say this one is the 680. So their time times the rate. The other one is 250. Time times rate. Add these together and you get 930t equals the total distance, which was 3720. You're going to divide both sides by 930, and you get t equals 4 hours. And again, you have the work and the strategy to get the answer, but word problems take time. You have to read them carefully, kind of look what they're getting at, what they want. Diagram will help, and knowing the formula, this will all help with the protocol for getting the answer. Now, here again, you want to pause, read it, see what you can do in developing equations. Well, here, this is the total amount that we're going to divide into two parts. So we'll say part of it is X, and this will be the bonds in a sense, and part of it is Y, and this is going to be insurance, I here. And here's the total amount of investment. We have to add 10 there. Okay, check your work. Now, we're going to say at the bonds, we're paying 7%. So this is going to be the X part, 7% of X, that portion of the total. And then the life insurance, this is the Y part, 12%. It's going to give us this amount of interest. So we're using interest equals principal times the rate times the time. The time is just 1 year. We know the rate and we don't know the principal, but we've defined it as a portion being X and a portion being Y. Now, they're asking us how much is invested then in the bonds, which is the X portion. So there are two equations, and I do suggest you get rid of the decimals here by multiplying each term by 100. And then we see what you get. Taking this in stages now, we've just written this one like so, and we've cleaned this up and written it this way. Now, we'd like one of these letters to cancel out. So which one do we use? And you can have your choice, but if you look at the question, they want us to find out what bonds are. We want to solve for X. So let's eliminate the Y's here, because we want to solve for X. So I'm going to multiply this equation by what to eliminate the Y's? And if you said multiply everything by 12, that is correct. So we're going to do that and then get our results over here. Again, I don't have a lot of room to work. Hopefully you have some nice paper to work on here. So multiplying through now by a negative 12, this gave me a negative 12x, a negative 12y, which is what I want, and that gave me a negative 444,000. Now I just copied this line underneath it. Here the 12y's cancel out, and I'm left with a negative 5y, 5x I should say. And then here, when I do the subtraction, I'm left with a negative 55,000. I'm going to divide both sides by a negative 5. Negative divided by a negative gives me a positive 11,000. And that is our answer. Again, lots of stuff going on here. And these are a little bit of a challenge. There's lots of algebra and arithmetic to do. Again, this is a very typical mixture problem. Read it over carefully, see what equations you can come up with. All right, let's see what you got. How many ounces of 15% saline solution? Well, we don't know that. So we're going to say that's x, and we're going to illustrate that as 15% of x must be added to 50 ounces of a 5%. Well, there's 50 ounces of a 5% to end up with a 10% solution of everything. So keep in mind here we had to use the x amount of this, and we already had the 50 of that. So again, look at this carefully. Get rid of your decimals. And this will be 15x. 5 times 50 is 250. 10 times 50 is 500 plus 10x. So we're going to subtract 10x, or transpose it. We get 5x. We're going to transpose or subtract this. We get 250 on the other side. Divide both sides by 5. We get x is 50, which is our answer. Now, I may be making these look easy. I had to think about them myself. They're not giving me any equations or anything, and hopefully this is useful to you. We're now going into graphing a little, and we're asked to find the slope and the y-intercept, and then use that information to graph. Well, this equation is in the form of slope-intercept. Which whatever is in the M position is the slope, and the B position is your y-intercept. Well, here our slope is going to be 4, and we think of that over 1, and our y-intercept is a -7. So on our graph, we plot -7 right there, and then we do the slope. Now, slope, recall, is the ratio of y units to x units, and it's positive, so we go over 1 for the x, mentally put a dot there, and then we go up 4. 1, 2, 3, 4. Our second dot there. So it looks like our y-intercept is -7 and a 0, and it looks like A here. All right. All right, that was sort of an easy one if you're familiar with that. And of course, it's multiple choice, so they give you various answers to choose from. Now here, we're going to do the same thing. Again, I would plot it on my graph here. Y equals mx plus b. So our slope is going to be a -1/2. That's what's in the M position. And our y-intercept is a -3. So a -3 is right there. And this is negative, so we're going to go, again, it's y units over x units. So we're going to go over 2 up 1. So our graph will look like so. And let's see if we can match that up here. And it looks like a D. Our y-intercept is -3, and then over 2 up 1. Yes. All right, let's go on. Now, as we get to about halfway through our review, we're asked to write the equation in the line in slope-intercept form, given the slope and the coordinate of the y-intercept. Well, again, there are a couple of forms of equations you should be familiar with. This one is standard form, and this one is, as we've mentioned, slope-intercept. So putting this y, they're saying our slope is 7. We have to put the x, and this is the form of writing the y-intercept, which would then be -8. So you see, that would be letter A here. Now, going on to number 19, we're asked to find the slope, and the formula for slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So our y sub 2 is 2 minus 4, and then a -1 minus a -7 makes it a +7. So the top becomes a -2. The bottom becomes a +6. And this simplifies to a -1/3, which is D. Again, there's lots of stuff going on in the background and things you would need to recall, but hopefully this review is helpful. Now for our halfway point, we're asked to find the slope of the line. Now remember, slope is a ratio of y units to x units. So we see our y-intercept is right there, and it goes over 1 in a positive direction, and then goes up 3 in a positive direction. So our slope then, we might think of it as 3 over 1, but normally we don't write the 1. So the slope is a +3. All right, we've run this a while, so I think what we'll do is divide this into 2 parts. So this will be part 1, half of it, and then you can take a break and come back and work on the other part.